Okay, here's a video of one of the examples that I did in class, similar to combinations of functions here. Here we given f of x is equal to 12, the square root of 12 minus x squared, and g of x is equal to the square root of x minus 12. We're going to first find f plus g, f minus g, f times g, and f divided by g, and then determine the domain for each function. So I'm going to start off with finding f plus g. Now I'll write this as f of x plus g of x, which means, by the way, f of x plus g of x. So we're combining the two functions together. And here your f of x is just simply the square root of 12 minus x plus the g of x, and that's just going to be x minus 12. That would be as far as I can go with that problem, because what's underneath the radical, underneath the square root, they're not the same. So we just leave that as is. Now we're going to find the domain for each of these functions here. Let's start with f of x equal to the square root of 12 minus x. Now with the radical function, if you recall, we always take what's underneath that square root symbol and then set it to be greater than or equal to 0. So I'm going to take that 12 minus x, set that to be greater than or equal to 0, and then get x by itself. So here I need to subtract 12 on both sides. That's going to mean negative x is greater than or equal to negative 12. Then if I divide both sides by negative 1, this will be x, but since I'm dividing both sides of an inequality by a negative number, that greater than or equal to symbol changes to less than or equal to. So here I end up with x is less than or equal to 12. Now, if I was to graph this on a numbered line, let's say 12 is over here. Now, for x is less than or equal to 12, at 12 I need a right bracket because 12 is included. Less than means it points to the left, so that means we shade everything to the left. So that represents f of x, the graph of, or the domain of the function f of x. Now for g of x, that's going to be the square root of x minus 12. That's given to us in that problem. And again, we have a radical function, so that means we need to take what's underneath the radical, which is x minus 12, set it to be greater than or equal to 0, and solve for x. So if I add 12 to both sides, that means x is greater than or equal to 12. All right, so now x is greater than 12 on the number line means this. I have a left bracket at 12. Greater than points to the right, so that means we shade to the right of 12. So this is my g of x, or the domain of g of x. Now, here when we're combining those two functions, we're looking for the intersection. And the intersection means this. We need to find out what's common in both of these domains. And the only thing that I see that's common for f of x and g of x is going to be that the number 12. Okay? That's the only thing that's common in both of these, the number 12. So in this case, my domain for the sum of f and g of x will be the number 12. I apologize for that. So that 12 will be the domain for the sum of the two functions f and g. Now for f minus g of x, I'm going to label this as part B. F minus g of x. This means f of x minus g of x. Here I'm subtracting the two functions here. And again, the f of x is going to be the square root of 12 minus x. Minus g of x, that's the square root of x minus 12. And again, I would go no further than this because I cannot combine those two, because what's underneath the radical are not the same. So I can't combine those. Now for the domain, I'm going to use those two graphs here that I have here. Because again, I'm finding the intersection of the two. That means I'm finding out what's common in both f of x and g of x. And you can see here again, it's the number 12. So the domain of the difference of the two functions is going to be 12. Okay, so that's part B. Now part C is the product of the two functions, fg of x, which means f of x times g of x. And here f of x is the square root of 12 minus x times g of x, which is the square root of x minus 12. Now notice I can multiply two radicals that have the same index. This is square root and that's also square root. So that means I can put all of this under one square root as the square root of 12 minus x times the square root of x minus 12. And I will go no further than that. I will not go ahead and simplify that. Okay. And again, for its domain, we're doing the product of these two. That means we're going to find what's common in both f of x and g of x. And once again, the number 12 is common in both the domains for f of x and g of x. So the domain for the product of the two functions will be, again, 12. And then finally, part D deals with the quotient of the two functions. So that means I have f divided by g of x, which means f of x divided by g of x. And here your f of x was the square root of 12 minus x. G of x was the square root of x minus 12. Now notice I got a square root divided by the square root. There is a rule that says here if you have, and I'm going to use a different color, if you have the square root of a divided by the square root of b, I can write that all under one radical, the square root of a over b. And the same holds true the other way. So in this case here, I'm going to write this as the square root of 12 minus x divided by x minus 12. Okay. Now, all right, now I'm going to simplify what's underneath that square root symbol. Notice I got 12 minus x, and then in the denominator I got x minus 12. Well, if I want to make 12 minus x, x minus 12, I can factor out negative 1. When I do that, then minus x divided by negative 1 will make that an x. 12 divided by negative 1 would be minus 12. So I have negative 1 times x minus 12 divided by x minus 12, and all of this is underneath that square root. Now let's simplify by dividing out the x minus 12 in the numerator and the denominator. I'll be left with the square root of negative 1. And then next, since I want to find out what the domain is, I have a radical square root. That means I'll take that -1, which is what's underneath that square root, to set it to be greater than or equal to 0. Anytime you have a radical expression, you're trying to find the domain, you want to take what's underneath it and set it to be greater than or equal to 0. So here I got -1 is greater than or equal to 0. Is -1 greater than or equal to 0? That is a false statement. So that means here the domain of this would just simply be the empty set. That means that there are no values of x that would satisfy the quotient of those two functions, f of x and g of x. Okay, so I hope that this video will help you complete that similar homework problem that is in section 2.6.